Welcome to a new video and episode on my experiment with fischertechnik robot interface. Programmed in this case in BASIC, beginners all-purpose symbolic instruction code, acronym, which controls an LED, reach from a switch, controls a motor, senses distance by sonar, and controls a power motor. And this is for a little bit later. In the past few episodes I demonstrated how a program intended for Windows can run and work on Linux as well, using the Wine emulator. Officially it's Wine HQ, so it's not drink, and by means of that I can use the for Windows intended Wine basic compiler. Rather old, but still works. So last time I made sure that this LED is connected to ground, sonar is connected to analog input, the switch is connected to digital input, two motors connected to motor 1 and motor 3, then this one is connected to output 3. Each motor connection has two outputs, and one output you can use like this. So last time I solved a problem with the algorithm, and now it regulates the speed, which is nice. I also included a serial cable which is hard-coded on a 13,400 baud, connected to, let me show you, connected to this USB to serial, or serial to USB in this case, converter cable. So I can use the minicom serial terminal for watching the output, and that output helped me to debug the program last time. Let me demonstrate. So after upload I select the memory, then program. Now it runs, as you can see. Then the small motor runs. Then this goes one speed, and holding my finger closer than 5 centimeters, it has a different speed. And via the serial terminal I can see when it is doing what. So next step is to do something else, add something else, and that needs a little bit of explanation the way I do it, because that is not according to the nice things here. So let's see how that works. And I intend to use some other software as well instead of minicom. So if you haven't seen this series before, then a little explanation. One terminal on my laptop with the upload program. So I tell which program to upload, which name of the program it is, in executable and then the destination, so it runs in the random access memory, while the program interface has 3 memories, 2 flash memories and the random access memory. Basic usually is not compiled but interpreted. In this case I have to compile it to a hex file, which is then uploaded and interpreted by the interpreter, loaded in flash. Then this one is obviously the source code in BASIC. Then let me name this one minicom serial terminal, with each print ending up here. And so this way I can check everything. Then this terminal where I compile everything, and here is the wine command, so I can use the Windows based compiler to compile the program. Obviously the camera, and what I also intend to do is Octave, scientific programming language, that I would like to use as well. So I have to use instrument control package, open CTY USB 0 on the baud rate, and then read. I haven't tested it yet, so that's going to be quite exciting. The only thing is you can only open the serial interface by one program at a time. So I actually will close this for now and start this program and see whatever happens. This is interesting. So why does it do it like this and then say I can't perform indexing operations? So it gives data, does not count. So if I now say, okay, what's the data? What's the count? It's 10. So that does work in its way. And it will be interesting to see if these bytes are indeed what I have captured in here and what it is. Nice to view later on. What I want to do now is something different. This is a photo transistor, and the reason that I have put it like this, let me make it more visible, with 2 crocodile beaks, is that I do not have a holder like this anymore freely available. So I hope this is going to work. I just have to plug 2 wires extra and see if that indeed, oh yeah, right, and of course put new code in and see if that is going to work out. Otherwise I have to take the holder from another project. Alright, so I connected this on in well, the way that I hope it will work. I didn't test yet. Software is input 3, digital input 3, if it is 0, print no phototransistor and 50 and phototransistor and 51 if it is 1. And the phototransistor can only have 2 settings, 0 or 1, or 2 results. Haven't compiled it yet. So, here goes. And then I will have to plug and unplug. Let me do that, otherwise I get an upload problem. Okay, do I have some results? Yes, I should have a result by now. Yep, that is correct. So, upload again. Done. So, with this flashlight, let's see if I have a result. Select and run. Okay, this works. And let me go here. So let me now just test for the phototransistor. And I do not see anything happen. So that means it just does, well, the motor runs. Right, I just realized that I made a slight mistake, and that is the following. It just goes on and on and on. And why? Because I had said that go on while the sonar is larger than 5. Well, larger than 5 is quite infinite. So I now thought if I limit the range. I already did that. And when I position them like this, it's even better. So one condition is smaller or equal to 5. Minimum reliable distance is 2 centimeters, so that is 2, 3, 4 and 5. And the other one larger than 5, 6, 7, 8 and 9 in my new definition. So taking the ruler, which may look familiar if you've seen this series before, 9. So this is one condition and this is the other. And let me show you a little bit better. So this is from 2 to 5 is one, 5 to 9 is the other one. And now it compiled. There's a point here with which I struggle to get both conditions valid. This compiles, but whether it does exactly what I want is the second one. So I compiled it now. So syntax wise it is alright. I have to upload. Done. So let's see if things work out. Work. And now shine. Shine again. that doesn't really okay, that is not entirely accurate in my opinion. Otherwise it is 30 degrees, and if it notices this, then yes, it is accurate. And otherwise it is not. It says larger than 5. This is clearly not larger than 5 anymore. So something is going wrong here. Yeah, it only does larger than 5. Which also means that my phototransistor is never being read. So unfortunately I have to disable something. I'm just not sure how and what to make it go nice. What I can do is put this into this procedure, so it will be repeated each time and again. Let me do that. Somehow the manual doesn't give a solution for this as well either, so who knows how this really works. Alright, I have now moved the whole if statement for the phototransistor into the bigger while loop for the while loop for the larger distance, and the restraint for 9 I have taken out for now. This is not structured, I know, but it gives no syntax error, so I'm very curious now how this will work. It's uploaded, so let's see. Start. This will work, and now I should be able to see something. Yeah, phototransistor and no phototransistor. And it says phototransistor all the time now. Yep. So this is working clearly. That's very nice. So now how about Octave again? No, not this one, this one. How does this work now? Okay, I have to find out how this actually performs, because something, or I have to do clear, that is maybe also an issue. How is this different from the other one? Not at all. Okay, so clear and shine with the flashlight. Maybe I should just go on for 20 and see whatever that gives. So shine and clear. Okay, I would have liked to see some number from here into the octave, but clearly I have to see what this is. If this is bytes, then I have to consult the ASCII table. Let me do just that. And my suspicion was correct, or my idea was correct. This is purely the ASCII table, at least. These are the numbers corresponding to characters from the ASCII table, and if you take this one, all these characters together, you get this text and this text put behind each other. So yes, that is exactly what it says. So if I want to do it in a different way, I have to translate these to their corresponding letters. The question is how to do that one. And for that I have to dive deeper into Octave language, if there's any way to do it. And then of course not just 20, but just like in minicom, consistently, continuously, because that's the only way that will work out. And this one works of course automatically, since it is a serial terminal, but this is basically what minicom does automatically, and I have to program that. So in itself it does work, just lower level than minicom. So how to get on with this? Well, I am first of all glad that the phototransistor does work, although I absolutely do not like the way the wires are going now. But for now I'll have to do. It will have to do. I certainly want to find out more about this part. Because why? The question is, why can't I make a while with two conditions? I have tried that for quite a bit, but that didn't work out. I get then syntax errors, which proves it doesn't work somehow. Okay, how to go on? Well, let me try a bit more with Octave. So, with this situation, how can I, using Octave, put things into characters? Well, obviously I managed to do that. I have to put the data between brackets and with the instruction character. And then I do get, in this case, a few times LED. So the question is, how do I get this permanent and not without a count? That is of course a different thing, because I am facing can't perform indexing operation for octal serial type, and that worries me a bit. So can I omit this I am just going to try. Not sure it will work out. And then, yes, that is command. Let's just try. Run. No. Clear. And once again, I don't even have to use the light, because then it will do something different. Invalid call, alright. That means that I will have to use count here. Just trying again. And oh, of course, I can use open, let me say clear, and go again. Correct usage is, oh, okay, I have to use something. A numerical. Let's then say 100, I don't care. So, again. And this will take a while, of course. At least that I think it does. Shining a light. And it says, alright, that's 100. And yes, it is not 100 words, but it is 100 characters. And LED consists of 3 characters. So let me do that again. See if I can get things to work otherwise. Pushing the button. And now something else should happen, and this is it. So now that's happened. And this data I don't need to see, because now with the semicolon this won't be printed, but I will only see this. And once again, and that's 100 characters. So it does work, but rather limited. So if I start this one again, I have, I have to configure, come on, configure serial port, and then I have to use D, yes, and here you see it. So basically the same. Shining again, and it says photo transistor. So yes, it does work nicely, and I think this is for now a nice ending. And with this result, or these results, I thank you for watching. So Yeah, this works quite nicely, and yeah, obviously I need to find a solution for this, because I do not like this technically. It works, but too experimentally. Yeah, thanks for watching again. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. And you can also follow me via Instagram and Twitter. Please donate to show your appreciation of my videos. You can donate via PayPal and Wired. And you can also become a patron and have your name mentioned. More information under this video. You can also find lots of information on my website. This is obviously going to be continued, so have a nice day and bye bye.